Hello, everybody, and welcome to the TeacherCast Educational Broadcasting Network. This is the TeacherCast App Spotlight. Thank you so much. Today we're talking all about robotics, modular robotics. Today we're going to be talking about STEM education and things that you can bring into your classroom to give your kids the lessons of their lifetime. We have a great company and a great guest today to talk all about this from Modular Robotics. We have Eric Schweikardt. Eric, how are you today? Welcome to the program. How are things?
I'm great, thanks, Jeff. Thanks for having me on.
And tell us a little bit about yourself. You're not too far away from here, Carnegie Mellon, right?
So I was at Carnegie Mellon a while ago. We're in Boulder, Colorado now. I was there for a PhD in architecture, oddly, which is weird. Nobody has a PhD in architecture. And while I was there, worked on robotic building blocks, future of architecture, maybe robotic building blocks. And the products we ended up developing turned into kid-friendly products, kid-specific products.
When was the turning point? When did you decide that architecture and education can merge and do something amazing?
That's a pretty good question. My friend was working at a science center, the Carnegie Science Center in Pittsburgh, and we were developing all these prototype robot blocks, prototype construction kits, based on the notion that everybody loves construction kits like Lego or Tinkertoy or Zoob, and they're super powerful tools for working with ideas, little models of systems to explore ideas. And a friend who was working at the Science Center came by our lab one day and said, "Hey, these are super cool. Can we bring them by the Science Center and use them in a workshop and get kids playing with them?" And we did. We started to do a little more of that, and we realized that they were a great learning tool for kids, maybe a little higher resolution or I guess lower resolution than professional architects might use, but a perfect resolution for exploring ideas of computational thinking and networking and robotics.
So I want to take a look at the product here, Modular Robotics. This is an amazing system that is combining architecture, robotics. Tell us a little bit about what teachers and students can get in a package, such as this.
Yeah, so I kind of want to pull them open and play. Maybe we can do that in a minute. But what you are holding up right here is our product called Cubelets. Oh, sorry, I'm going the wrong way. Not totally used to the mirror view here. And Cubelets are robot blocks. So when we were kids, we played with Legos. We played with wooden blocks. I remember these like Bauhaus-style wooden blocks that I used to play with that my mom got at the Museum of Modern Art. We played with all these different types of construction kits, and construction kits help us build and work with our hands and learn about the world by building stuff. And Cubelets are an exploration on what's the next generation construction kit going to look like. So they're blocks. Each one has robotic stuff inside of them, and you build robots and learn about technical subjects and non-technical subjects as well, just by snapping plastic stuff together.
The website is modularrobotics.com, and I'm looking at these things. There's a lot of different configurations for this. Eric, would you consider this programming? Is this coding? Is this engineering? Is this all of the above? Where do these fit in here?
So there are a couple ways to play. Maybe we should just get started playing, but the first level of play is just by snapping blocks together. And that's what most of our kids, most of our teachers and students are doing, engaging in the first level of play. You just snap blocks together, sensor blocks, action blocks, distance sensor blocks, Bluetooth blocks, snap them together and build robots without any programming. And that's in contrast to typically how people build robots, both kids and adults. I mean, pretty much whenever you're building a typical robot, it's this two-stage process, right? Like a kid using Lego Mindstorms or Vex or any number of the awesome systems that are out there for building robots. First, you build a plastic and metal robot, right? The body. And then you shift your attention over to the laptop and you program its brain, you program the behavior, right? That's Rene Descartes, Cartesian mind-body dualism, two separate things. And it's super powerful. And you can build a lot of great robots that way, but it's not how real world systems work. It's not how social systems work. It's not how biological systems work. It's this artificial separation. We're running something much more complicated than a procedural C programming in our head. We have parallel processes and other things happening at the same time. So Cubelets is a very different system. When you're snapping together Cubelets, you're obviously building the body of the robot, but you're also programming its brain. The little modules, depending on how they're physically configured, talk to each other and determine the behavior of the system. So instead of programming a robot's one brain, you're snapping together 20 different little robots and then seeing what happens.
So does that mean that you're snapping together 20 different robot brains to make one? And what is the end goal here? Is this to teach kids how to make robots, to make robotics, or are they creating a machine to solve a problem?
That was like 3 great questions all in one, and I'll try and take a stab. You're snapping together 20 little brains. So each cubelet has a tiny little computer inside of it. Each cubelet is a brain itself. And when you snap together 20 brains, you're creating a robot construction. And it's maybe not one brain anymore. Maybe you consider it a brain, semantics. Those things are kind of hard. But when you snap together 20 brains, then you're creating a network or a little society of brains that has some sort of higher level emergent behavior. So we'll talk about typical STEM subjects and typical technical subjects that people teach and learn using Cubelets as a tool. But the next part of your question is an important one for me, which is kind of why I get up in the morning and do all of this stuff. Cubelets are designed not to teach kids about STEM. Cubelets are designed not to teach kids about robots. Cubelets are not designed to be a technical thing. Cubelets are intended to be a model of a complex system that kids can use and build and manipulate and start to gain intuitions about how complex systems work and how patterns emerge. So thinking really like super high level about the world and big problems, societal problems, economic problems, environmental problems, all these like big, great problems that we have a really hard time solving, that we have a really hard time thinking about. These are all complex problems, complex systems, problems of lots and lots of little agents interacting, doing stuff together. And then when we step back and raise our level of abstraction, have an emergent behavior of a vastly degraded natural environment or a crazy political system that nobody's benefiting from, or corruption or a bad economy that we have a very hard time solving from a top-down program a solution approach, right? These are all complex problems. We need to dig a little deeper and understand how lots of little elements are working together and creating nuanced behavior and giving rise to higher level emergent behavior. I know all this sounds sort of crazy, but the best way to think about stuff like this is by building little models of it, little toy systems that we understand.
Well, I love the idea about teaching kids robotics. And, you know, you've kind of hit the nail on the head here with why it's important of building these networks of learning, building these networks where kids can create different items that they want to create. At what age do you think we should be teaching kids about robotics and, really molecular design with all these different components?
Yeah. I think robotics and physical stuff can be really excellent tools for helping kids explore important concepts, important computational concepts, networking, recursion, loops, inputs, outputs, feedback, like all this really high-level stuff. So people are talking a lot about computational thinking, and that usually ends up being, well, let's teach kids how to code. And coding is just one sort of language that we can use to think about computational and critical concepts, right? But a lot of people hate coding. Most people hate coding. A lot of the people who are saying that all the kids need to learn how to code haven't written a line of code in their life. I've written lots of lines of code in my life, and I like computer programming and C and Python and Perl and all of these great things. I think they're great ways to think about the world. But I totally appreciate that many, 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 many kids are just going to hate computer programming. And I think that's fine, because computational thinking, all the subjects, complexity, everything that we need to do a little more of in our world is not necessarily computer programming dependent. It's computational thinking dependent. And robotics can be a great way to hit a bunch of other kids who are not necessarily drawn to code, especially robotics kind of like Cubelets, which are a little easier to play with, a little easier to get up to speed, building with your hands for kids who are less inclined to type thousands of lines of C code on a screen. So yeah, I think robotics are a great way to teach not just about typical STEM things, but as models of natural systems, models of environmental systems, models of social systems, even literacy, things like that.
Well, it seems like it's easy for kids to pick up STEM, robotics, because they don't know any different. They're just picking up and they're just sucking everything up like a sponge. What advice would you give for the teacher that's out there that might be told that they're starting a STEM program in their school, the teacher that might look at their kids and say, well, they know more than I do, and it's okay, I'll just let them still continue to know more than I do? What advice do you give those teachers that need to find this information so they can be the leaders of change in their schools?
That's a good one. It's a hard problem that I'm not in any position to solve, other than suggesting that maybe a good approach is to just do your best learning along with the students. So it's totally fine to explore new stuff, and maybe great to explore new stuff with students and show them how you might approach understanding the new technology, building a model in your head of the new technology. I'll tie it back to coding just for a second. An interesting example, like in Modular Robotics, we hire a lot of software developers, and we never put out requests for software developers that know a particular language. Oh, we're looking for a Ruby on Rails software developer or something like that, a Python software developer. We never do that. The great software developers that we hire are all software developers who are language agnostic, who are very good at just looking at a new piece of programming language or a new framework, reading through the documentation, trying a few things, getting up to speed, and learning. And I think that's a really important skill. It's far more valuable than actually knowing how to write great code in Python, is learning how to learn. And if there's anything that teachers or, formerly known as STEM coordinators or about to be STEM coordinators could do, I think it's probably best to model for their students the desire and ability to learn new stuff without being scared of it. Mm-hmm. So, maybe it's starting with something as simple as Cubelets, little robot blocks that you snap together, and maybe working through the next thing, but modeling for those kids that these things don't necessarily need to be scary, that we have plenty of room in our brains to try these things out, and it might take time, and it might be embarrassing, and I might be the teacher that totally screws everything up in front of a class of 30 screaming kids, and that's fine, because failing early and failing often and iterating is part of learning.
Well, let me pick up on something that you said. You said, knowing the way to learn things. Is it really more personal than that? Is it learning how you learn things? I mean, it seems like a lot of times when I'm speaking with STEM type teachers, they just think differently than I do. Being a music person, I think visual. A lot of people in robotics think visual, but they're thinking of it in ways that I'm just not used to thinking. And I know for myself, it takes a little bit of time to translate what they're saying into my language and then retranslate it back to them. It seems like also like a lot of robotics work with different types of things. For instance, the Cubelets here, you have a Lego component, right? You have a system that snaps into Lego. So not only are you using the Cubelets, but you're using another system as well. Is it easy picking up something when you know that you're trying to learn multiple systems on top of multiple systems?
Sometimes. So maybe after this, let's just jump in and play with some Cubelets. So
sure.
We can kind of play together and do a little bit of a learning experiment. I wouldn't say it's easy. I mean, learning stuff is never easy. Maybe even motivating to learn stuff is never easy. But kind of going back to that just like love of learning and being open to making mistakes and learning thing, my biggest pet peeve, maybe I have a bigger one. Okay, one of my pet peeves is when people say stuff like, oh, my computer's broken. Eric, would you come and fix my printer because it's not printing? Sure, I'll be happy to fix your printer. Okay, here's what I'm doing, and I'll talk through how I'm fixing the printer, and I'll open something up, or, everybody helps their grandmother fix their printer. And people will often say stuff like, I don't want to learn how it works. Don't tell me how it works. Just fix it for me. And I think that's like awfully misguided and closed-minded. We use like 6% of our brain, right? There's 94% of the brain clicking around in there, having daydreams, thinking about other random stuff, thinking about lunch. It's just free space. It takes as much time and energy to avoid learning something as it takes to learn something, right? There's not a finite amount of space in there. So if we're going to like sit there while somebody fixes the printer, let's kind of try and learn it while it's happening. And so that kind of open-mindedness to new things and a willingness to learn, and to never say something like, I don't want to learn how it works, just do it for me. I think is one of the most valuable skills. And it lets kids understand that learning something is not painfully time consuming or painfully energy consuming.
All right, Eric, why don't you show us a little bit about Cubelets?
Okay, quick demo. So I've got a Cubelets 12 kit right here, which has 12 Cubelets in it. Open it up and kind of talk over this for the benefit of our audio listeners. There's an instruction manual and a bunch of robot recipe cards that are showing different robots and different Cubelets that you can build. And then in here, there's a little USB cable that can go away and a brick of 12 Cubelets. So you can see that each of these little 40 millimeter blocks is different, with the exception of a couple duplicates, and they all do different things. You can see these two little yellow Lego adapters that you just mentioned, one with little male pegs on it and another one with little sockets on it. You can use those to combine Cubelets with Legos. Turns out most classrooms and homes that we sell Legos in have thousands and thousands of dollars, or Cubelets in, have thousands of dollars of Legos in them already. And they make great sculptural and structural elements for a Cubelets robot. But what's going on here is all of these little cubes. And you can see that they snap apart and they snap back together with little magnetic connectors. Super easy. And there are a few different types: sensors, thinkers, and actors. So what's the definition of a robot? A robot is any device that senses, thinks, and acts. You could say senses, plans, and acts if we wanted to be less provocative, but it's a podcast, so let's be provocative. They think. The black cubes are sensors. So this black cube is a distance sensor. It's got two little eye-looking things on it where it shoots out and receives infrared light. We've also got a couple other sensors, like a black light sensor like this, and another distance sensor in the pile. The clear cubes are all actuators. So sense, think, and act. Or you could say input, processing, output, whatever. This one's a flashlight. We've got a bunch more clear Cubelets that do other things too. And the colorful ones in between are the thinkers. So quick demo. Let's see. This blue one right here with a switch on it and a little USB port is a battery Cublet. Every robot needs a battery Cublet. Let's snap on a distance sensor and also snap on a flashlight. And we'll see if this blows out the monitor or the camera or not. Simplest possible robot ever. When the distance sensor detects my hand over here, it sends numbers to adjacent Cubelets and the flashlights turn on. So we just built and programmed a robot. Flashlight is next to the distance sensor. We could take the flashlight Cublet off and instead put a little rotating Cublet that spins on top. And then I'm going to put the flashlight Cublet back on top of that. And it's a similar robot, but now when the distance sensor detects objects like my hand, both the rotate Cublet and the flashlight Cublet actuate and turn on. We could make a little mobile robot with another action Cublet that has wheels on the bottom. And I'm going to scoot this down a little bit so that video folks can see. But here's a drive Cublet on the bottom and a distance sensor on the back, battery Cublet on top, 3 Cubelets. When I put my hand in front of it, it scoots away. If I take this and flip it to the other side, I still have 1 distance Cublet, 1 drive Cublet, and 1 battery, but the behavior is reversed. Now when it detects my hand, it scoots away from it. We might want to add some smarts in there. So let's add a pink Cublet. This is the inverse Cublet, and it will reverse the behavior. So here's the first robot that we built, which when it detects my hand, scoots toward it really fast. Let's take the pink Cublet, put it in between the distance sensor and the drive Cublet. And now we have a robot that drives really fast until it detects my hand and then stops. So the behavior is reversed. By adding the colorful Cubelets, we're doing some very explicit programming, but we never have to write things down on the screen.
That is amazing. And that is something that you could easily put in the hands of any student, any teacher, I would say any grade level. I mean, I was working in kindergarten today. Kindergartners can put this stuff together and have a great time learning about robotics and programming.
Definitely, I think so. Kind of one of the surprise areas that we found a lot of success is with 4 and 5-year-olds, pre-K and K, simply because there are no other products in the market. So Cubelets, while they're little robot blocks that we're snapping together and we're using the very lowest threshold form of play right here, are actually a super high ceiling system. It's 12 little robot blocks in a box. Each one is end user programmable. Each one is remote controllable, and you can put them all together and have this distributed parallel processing machine, and you can reprogram one cubelet and then see how its behavior has a ripple effect and changes the whole behavior of the entire system. It's immensely powerful stuff, distributed robot programming for kids. But you don't have to go there if you want. You can just snap blocks together and make cool robots that drive around.
Well, Eric, what kind of things have you seen kids do that might have surprised you? You know, maybe something that a kid has done and you're like, I've never thought about that before.
Good question. We have lots of kids making conveyor belts and stuff with drive cubelets. We have lots of kids building just weird constructions and trying to race them and adding Lego ballast and things like that onto them. Let me show you the first really weird thing that we saw and understood with Cubelets. This was back in like 2006 when we started, that made us think that it's a super powerful system. I'm going to build a robot in front of me right here, and I'll scoop the camera down so you can see. I have a drive cublet with wheels on the bottom, 2 of those drive cubelets. I'm going to put those down next to each other. I'm going to connect them with a dark green blocker cublet. What that one does is it still lets them pass power back and forth, but it blocks the data. It stops them from talking. You could consider it like an insulator or something. I'm going to add on 2 different distance sensors pointed towards me, and then I'm going to take the battery block that we're familiar at to power the whole construction and snap that onto the back too. Right? Simple robot. 1, 2, 3, 4, 5 cubelets. And I'm going to put my hand in front of it. Actually, I'm going to turn these around the other way so I get the behavior that I intended. And I've just built a little robot that's steering away from my hand. Okay, so I've never done any programming here, but I've just built a little robot that drives away from my hand, looking intentional, looking like it has pre-programmed behavior to avoid objects.
I have a 2-year-old that does the same thing, Eric.
Sorry?
I said I have a 2-year-old that does the same thing.
Yeah, and the 2-year-old didn't have a program written by anybody that told your 2-year-old what to do, right? It's just a function of your 2-year-old's biology and mind and everything kind of working on its own and coming up with these rules. It looks designed, it looks intentional, but it's not. It's an evolutionary thing. Nice. So something like this is a really creative way to think about the world, in which it's not just this robotic world programmed by somebody from a top down, but it's a model that can help people understand how intentional looking behavior in the world can evolve from simple parts that we understand.
What are the possibilities here? I know you said that was a Cubelets 12 pack. What types of packs do they come in? Talk to us a little bit about what a school can purchase and how big can a system like this get?
So it's pretty much unlimited, although Cubelets are expensive. The kit of 12 that we were showing right here is over $300. And I know that's it's crazy to a lot of teachers. We manufacture everything in Boulder, Colorado in our own factory, which is basically the reason why things are so expensive. Let's see if I turn the camera around over this way. Our factory is dark because shift on Tuesday ends at 4:30, but we've got a bunch of people building things here in the States. So that's the disclaimer that Cubelets are expensive, and one of the primary things we hear from teachers is that they have a hard time affording them or working them into the budget. From some teachers. Mm-hmm. Some teachers have lots of extra slush money and funding that they can spend on stuff like this. So a Cubelets 12 kit is great for one kid. We also offer a bunch of different educator packs. The typical one is around $1,000, and that's good for a smaller classroom. It has a bunch of battery blocks in it, so multiple kids can play at the same time. Multiple kid groups can play at the same time. And we also have a few offerings that are up from there, more expensive, the $5,000 offering and the big Pelican case that's better to be a shared kit amongst lots of classrooms and things like that.
Nice.
With all of those kits, all of the curricula and lesson plans and activities and teacher training materials that we've developed come free. So all of that stuff is available for free and for perusal on modrobotics.com. There's an education tab up at the top. And it's crazy to me. It blows my mind that everybody's used to paying for curricula. I come from kind of the open source information wants to be free community. But, I understand that good curricula is an important product and somebody has to develop good curricula. But we've taken the model of publishing all of the lesson plans, activities, teacher training materials that we have for free and online and making our money on hardware instead.
Speaking of working with kids and working in a class situation, tell us a little bit about the battery packs. If I was a teacher using this all day, how long before I need to recharge the battery on these devices?
All day long, you should be okay. We just got back from Toy Fair in New York City at the Javits Center, and our battery Cubelets were lasting for solid 8-hour days. Over time, of course, batteries do degrade, though, and if you have a Cubelet construction with an enormous number of motorized Cubelets, that drains the battery quickly, and most kids, when they play with little tiny robots, want to add a lot of motors and make things go fast. But a battery Cubelet, even in minimal charge, should last 4 hours or so. And there's a little micro USB port on them to charge them. Most of our educator packs come with batteries so that you always have effective battery charging hubs charged and managed pretty well. I just got back yesterday from the Denver Museum of Nature and Science, where they've got this big exhibit called Robot Revolution. And on the way out, everybody plays with Cubelets and builds their own robots, which is exciting. And they have battery Cubelets out on the table all day, and every once in a while have to go and change them up. But they last a while. The miracle of lithium polymer batteries.
Very, very cool. The company is Modular Robotics, and it is Modro Robotics, M-O-D-R-O. Yeah, we say that one more time. The company is Modular Robotics. Eric, why don't you tell us a little bit about where we can find you and how to get a hold of you in case we're interested in bringing modular robotics into our classrooms?
Sure, definitely. Find us on the website, which is modrobotics.com, modrobotics.com. Cubelets are available at a bunch of awesome educational resellers. They're also available on our site. They're also available on Amazon. But hit modrobotics.com. Watch some of the videos on our YouTube channel, which is also Mod Robotics. And yeah, get in touch with us.
And if you're interested in learning a little bit more about STEM, check out this and all the other great shows over on the TeacherCast Educational Broadcasting Network. We've got some pretty interesting things happening these days on our brand new site, beyondthehourofcode.com. Eric, thank you so much for taking the time to be here. Certainly, we want to have you come on later and share the great stuff with robotics. And perhaps, I don't know, maybe we can get some of our teachers involved in robotics and make life a little bit easier for these teachers who are going off to create amazing STEM things in their classroom. Eric, thank you so much for being on our show today.
Jeff, thanks for having me, and congratulations. I love the podcast.
Thank you so much. And, of course, thank you guys so much for making TeacherCast your home for professional development. There's, of course, several great ways that you can reach out to our show each and every week. We love it when you find us on Twitter @TeacherCast. Leave us a voice message over on teachercast.net/voicemail. Email us at feedback@teachercast.net. And, of course, this and other great shows can be subscribed audio and video over on teachercast.net/iTunes and teachercast.net/YouTube. My name is Jeff Bradbury. Thanks so much for joining us today. Until next time, keep up the great work in your classrooms and continue sharing your passions with your students.